reflections, rotations, and translations. Today I'm going to review one of those with you. We already talked about translations, and you guys were really good about adding or subtracting for the x, for right or for the left, and then adding or subtracting to the y for an up or a down slide or translation. But now I want you to see what happens with a reflection. So we're going to reflect over this y-axis. So in Desmos, I put in the points 2, 4, 1, 5, 6, 7, 2, 4, closed it, and made a triangle. So if we reflect this over the y-axis, what used to be 1, 5 is now going to be what? Negative 1, 5. And so instead of, we're just going to label this, so that's A, B, and C. So this is B what? Prime. Good. What used to be 2, 4 over 2 and up 4, if we go over the y, is now going to be negative 2 and then 4. 1, 2, 3, 4. So there's our A prime. And so now it's negative 2, comma 4. And then C used to be over here, this pre-image at 6, 7. When we go over the y, it's now going to be at what? Negative 6, 7. Talk with your team about what do you notice for each of these. Go.
It's just negative. It's just negative. Yeah.
It just takes the first number.
Is that double prime or is that like
You're moving it. You're changing the x-axis numbers to
It's still the same shape.
yeah.
So that was a quick turn and talk because there was a one question, but I want to hear from Team 3. Team 3, what did you guys say? What did you notice when you reflect over the y-axis? What did you notice?
It's exactly flipped, and you just had to make the x negative.
So the x coordinate is negative, so it's flipped, so it's the opposite. So what was that 2 is now negative 2? Clap twice if you all agree with that. 1, 2. Awesome, and that was also a double clap for Team 3. You're absolutely correct. So then, my question is, if we reflect over, not the y, but we take our image here, this pre-image, and if we reflect it over the x-axis, instead of over the y, what do you think would happen? Talk with your teams, and then we're going to do it. Go ahead and talk with your teams.
So it'd be down there now. Yeah. Okay, so would that be double prime? If it was reflected over the x-axis instead of the y, then what would it be? It'd point down.
Prime or just a normal?
It'd be flipped.
Oh, it'd just make.
From the x, it just flips to the.
It would make the y. It'd make y all negative. Make all the y negative.
Yeah, instead of the x.
Okay, so I'd like to hear what your teams have discussed, and I'd like to hear from Team 5 this time. My facilitator of Team 5, what did you guys discuss?
The y would become negative.
What do you mean by that?
Like, the x would stay the same, but then the y would be negative. So, like, 7 would become negative 7.
Okay, so A at 2, 4 would become, A prime would now be what?
It would be 2 comma negative.
2 comma negative 4. So 2, so this part stays the same, but now we're going to go down here. 1, 2, 3, 4, 2, negative 4, and that would be A prime. Clap twice if you agree with that. 1, 2. You guys are all correct. So 6, 7 would be what?
6
negative 7. Very good. So I have to go 1, 2, 3, 4, 5, 6, 7. Good. So that is now C prime, 6, negative 7. And what used to be over here at 1, 5 is still going to be at 1, but it's going to be at negative 5. 1, 2, 3, 4, 5. So there's my B prime. And if I connect those, and let's not label the coordinate right in the middle of the triangle, do you see a mirror image over the x-axis as a line of reflection?
Yes.
Okay, and we know that from A to A prime, these are the same distance, and they are also what? What other relationship did we discover? If I draw a line from A to A prime, what happens with this line and the line of reflection?
Perpendicular.
Are they perpendicular or parallel?
Perpendicular.
Right, so this from here is going to make a perfect 90. C to C prime is going to make a perfect 90 degree with this line of reflection. And we also discovered that they are equidistant, so they're the same distance from the line of reflection. Pretty cool, right? Now, last period someone said, this is so much fun, can we reflect again over the y-axis? And so we did that quickly. So we went from over here, A, which was 2 comma -4, and we said if we reflect over the y, that it's going to be -2, -4, agreed?
Yes.
Okay, so there's -2, and then there's my -4. And so then B prime, which was 1, -5, would be what? -1, -5. Good. And then C prime, which was 6, -7, would be -6. Good. -7. Okay, and then what we saw when we connected that, what do you notice? So it's a double reflection. Okay, but also if I label this point right here, A double prime, this point is -2, comma what? C prime is -6, comma, and then B, in this case double prime here, is -1, -5. And from the original, what do you notice? Remember, this was 1, 5. They're all what? They're all opposites. So 1, 5 becomes -1, -5. So we had a double reflection, so we switched the x and then we switched the y. Now that's the same as what kind of transformation? It is a double reflection. Boop, boop. Same as a rotation. How many degrees? 180. What could I do to go from A to A double prime? What could I do to see the degrees? So if I connect them though, and I go through the origin, how many degree turn is that? 180. Do you remember how the 90 made a perfect L with the origin?
Yeah.
And now this makes a perfect 180. Is that pretty cool? So a double reflection, so a reflection over the y and the x, turns out to be the same as a 180. And that means the rule for a 180 is basically just to do opposite, x and y. Okay, we're not going to look at the rules for a 90 degree today. We're pretty good at those. But I just wanted you to see this relationship between the x and the y's and what happens when you go over the y-axis or you reflect over the x. And then this cool relationship with it being the same as of 180 degrees. Do you have any questions? What questions do you have about this rigid motion? What is rigid motion? I have a question for you. What is that? What's a rigid motion? Talk with your teams about what you think it is. Go.